video from a Siemens PLC programming series, and today we are going to learn how we could connect the sensor to our PLC and get sensors data or information. So before I go start to talk about that, let's start with the definition of the sensor. So what is the sensor and how it works? So as you can see here, I add one simple definition for the sensor. Sensor actually detect a physical, chemical, or biological quantity and convert its data to the electrical signal. So in other words, in one side of the sensor, you have the physical, chemical, or biological quantity, and in other side, you actually get related voltage or current related to this physical quantity. So for example, if your physical quantity is temperature and your temperature change from 0 to 100, this is what you want to monitor. So definitely this sensor able to change the 0 to 100 Fahrenheit or Celsius degree to the one voltage or current range. So it could be any physical quantity, speed, acceleration, temperature, pressure, everything. Okay. So in other words, so we could say whatever you see in the input of the sensor is expected physical variable, and it's actually somehow the sensor change that to the voltage or the current range, which is related to these physical quantity or variables that you have. So in as I mentioned, these actually changing could be these changing this physical quantity to the current or voltage. But for the PLC that we use, which is a 1200, so you could just have the analog input as just the voltage, not current. But in the other cases, and even in some other brands or PLCs, able to get both the current and also the voltage. But whatever you see in your PLC analog input, so for this specific model of the Siemens, not all of the Siemens PLC, these specific models that we use is just able to get the voltage range between 0 and 10 volt, which comes from your sensor. So I talk about the analog inputs. Let's see where is the analog inputs in our PLC that we use. So if you go to the PLC documentation, which is easily, you could actually Google that and get this PDF file that you see. Let I go to the first page that you see what you need to Google. So if you go and Google for Siemens S7 1200 program and control system manual, so it's actually a PDF file which is including 1614 pages on it. So you could actually find all info related to your PLC inside this PDF file. For now, I just want to see where is the analog inputs, that why I'm looking for analog inputs. If I have the sensor, definitely I could connect my sensor, these analog inputs that I have in my PLC, and somehow use that data in my ladder logic or in my program. So let's do check page 1379. So let's do back here and go to the page 1379 and see what we could see. Yep. So if I could zoom a little bit. Okay, so yeah, it should be here, the zoom. Okay. So as you could see, this is our PLC that we use. We already use these I/O pins that we have, digital inputs, and close to this, you could actually find the analog input. So you have, for these model that we use, you have two analog inputs. One is the A0, the next one is A1, and this 2M that you see is the common. So that means you could connect this one to a one sensor and this one to another sensor. So totally you could actually connect to a sensor and use the data inside your PLC that you have. So if I turn on my video to show where is exactly these inputs, so see here is my digital input, which is 0 to 7. We use these a lot. So close to them, you see here it says analog inputs. So this is 0, this is 1, which you use these ports, and here you have 2M that I mentioned. So that means if you want to connect or wiring the sensor, so definitely you have two options. If this is 1, you could use the analog input 0 and or analog input 1. So as I mentioned, you couldn't actually put the current here because these specific models not actually working with connect with the current that only it's able to accept as a voltage. So that means your sensor should be converted physical quantity with a range of the voltage between 0 and 10. Then you could actually connect that to the analog inputs that you have. So let to do this. Let to somehow simulate one sensor and see if we have one sensor, how we could get the sensor info inside the logic and get that data. So definitely for doing that, you need the sensor. So here I don't have a sensor. Instead of I'm going to use one DC power supply, which able to control the DC output voltage between 0 and 10. Why? Because what exactly this sensor doing, it's actually get the physical value and convert that to the range to 0 to 10 volt. If you have a variable DC power supply, definitely you could mimic this sensor because what sensor do convert this physical quantity to the range between 0 to 10 volt. If I have the DC power supply which able to give me 0 to 10 volt DC, so definitely I could mimic with a sensor that I have here, and really you don't need to have that sensor. But definitely if you have a sensor, you could definitely add that. So if you do that with this variable DC power supply, definitely you could use any, if you change that and use any other sensor, the circuit or the program that you use is the same. So I'm suppose I have a sensor which is able to give me 0 to 10 volt. So I use the variable DC power supply. So let I show the video what I have here. So this is my DC power supply. So here it's the output of that, which here with changing this knob, I'm able to get 0 to 10 volts. See, I'm changing this knob, now get is 1 to 0. So then if I increase that, I'm able to get now I'm 8, 9, and finally 10 volt. Okay. So easily I could produce the DC voltage 0 to 10 is here. So I suppose this is my sensor which able to convert the physical value to range 0 to 10. So this is my negative. So see where I connected my negative. The negative comes to the 2M, which is this one that you see. This is a positive. I actually connect to this A0 that I have here. Okay. So that means I have my sensor which is connecting to the PLC. So what's happened inside the PLC and how you could somehow get this sensor range and able to use that data. So here I actually put, let I turn this off. We don't need these. We don't need this for now. So this is our PLC. What's happened inside the PLC? I get this DC voltage from the sensor, for our case from the DC power supply. So it's first come to the PLC analog to digital converter. So based off its resolution, so for this specific model that we have a 71200, so it's actually convert these analog signal, which is between 0 to 10 volt in the integer numbers, so the digital numbers, and its range is between 0 to 27,648. Where I get these info definitely in the PLC manual, right? So if you search that easily, you could find that. So that means whatever you give 0 to 10 volt to the analog input, so analog digital converter inside the PLC convert that to the 0 to 27648. What I want to have, I want to see these data in exactly in the form of the physical value inside my PLC. So for doing that, you need to use actually two instructions that we have in TA portal. The first instruction is normx, the next one is the scalex. So here I put these instructions. Later on I show in the TIA portal how you could find these blocks. So what's the main job of the normx? It's actually normalize these value that you see. You have the 0 to 10 volt is convert to the digital value in this range. Just be careful. Definitely this 0 is corresponding to the 0 volt and this number is corresponding to the 10 volt. It is exactly linear conversion. So that means it changed this range to this range that you have. So then these instruction normx change this range that you have to normalize that. So that means the output of that is between 0 and 1. So again, 0 is matched with this 0, which is somehow is matched to the 0 volt, and 1 matched to this number, which is somehow matched to this 10 volt that you have in output of your sensor. So now you are not still done because you want to see these, for my case, these 0 10 volt. I want to have or see these 0 to 10 volt in my program. So definitely I need another instruction or unit, which is the scale X. Then I scaling these range from 0 1 to the minimum and maximum range that your physical value want to measure. For my case, I just want to put to the 0 to 10 volt. I want to see whatever I have in the analog input in my ladder logic. So for that reason, for my case is minimum should be 0, the maximum will be 10. So that means whenever I change my DC value in my variable DC power supply, I will exactly able to see that numbers in my program. So if your sensor is, I don't know, level sensor is, this is temperature between you measure 0 to 100 degree Fahrenheit or degree Celsius, so definitely should be 0 to 100. If you are measuring the level between 0 to 100 inch, definitely should be 0 to 100 inch. So that means whatever you have here should be exactly the same physical value that you are measuring. So for our case, for this case, we just want to see the 0 to 10 volt that we have in our analog input. That's the reason I will put 0 and 10. So this is actually the whole ladder logic that you need. So let's do back to the TIA portal and see how we could implement that. So as you could see, you just need two units, the normx and scalex, where you could find them. So as usual, you just close the instruction. So in the instruction, you should, let's see, let's go up and see this one, the conversion operations. So you click on that. So the two last one is the scalex is this one, and the normx is this one. So as usual, you just need to drag and drop on your ladder logic and you could get them. So let's see which value you need to give. For normx, so here you need two adjustments. One is, if you click on that, it shows the data type that it get from the input. So what is the input of the normx back here, and you tell me what is the input of the normx. It is actually this range, which is the integer number, right? So that's the reason I put input is integer, and the output is known between 0 1. So that's the reason I select is the real, because you need the real number, right? The range change from 0 to 1, and definitely you need the real number to represent them. So as you could see, what should be the minimum and maximum in the input of the norm definitely is this range that you have. So what is this range? 0 to this number. So I actually give exactly the same number. Whatever I comes is this range, which comes from non-analog digital converter of the PLC. So then what is your actually input value? This one is important. So where this value comes, what is your input value? The input is your what is what's actually the input, the real input. That means this comes from your analog inputs, which should be the channel 0. So if I turn this on, again, what I did here, I connect this output of this DC power supply to, so that I show. So I connect actually the output of my variable DC power supply to the A0, okay? So now somehow you need to tell in your TI portal and in the norm X where is your analog input. So here you say the range is minimum max is this because of your analog digital converter that you have. These value you should address where is your analog input, which for us is channel analog channel 0. Okay, so for finding that channel, so you need to do this. So I click on the device management. So yes, so device management. So then you comes to the property, then you go to the general. So in the general, you see the analog inputs. One, as we already know, we just have two inputs, right? So channel 0 and channel 1 for this specific model. So whenever you click on channel 0, it shows what is the tag number for your channel 0. So channel 0 is IW64. So that means it is a word and it is an input and its number is 64. As you could see, I couldn't actually change them, so you need to use this number, so because it is somehow inactive. So as I mentioned, this model couldn't give you a current to as a input, analog input, because here you couldn't change that, right? So if you, in some other models you could do that, you could have current and voltage as an analog input, but here as you see it's inactive, it's just accept the voltage. So that's the reason you just use the voltage. So I get this number, which is IW64. So see if I click on channel 2, it gives you other numbers. So again, IW66 is the memory number for the data for channel 1. So, and again, you couldn't change them. So one is 64 and another one is 66. And definitely you know why. So if you watch our previous video, which is the internal addressing, we mentioned the word actually is 16 bits. Whenever this is 64, definitely next one should be 66 if you want to avoid the address conflicting. So if you didn't watch that internal addressing in PLC, please watch or click on the link that we have in the top of the screen. So back here, we just use channel 0, so that's the reason we just use these IW64. Let I minimize this. Just remember that number IW64, so let's minimize this. And that's why you use this value here. So see if I click on this. So definitely you could write this tag number. You just write here percentage IW64, which is somehow you are telling what is the input of this norm X. The analog value comes from the input 0, which is in IW64. I actually add the tag number. You could add any name that you like. I say analog input channel 0. So here you say my analog input is here. It's come in the range between 0 and 10, and the digital analog to digital converter changed that to the range to 0 to 27,648. So that means I made here. So whatever we have here, I already made. Somehow you are not doing anything, that's already inside the PLC, but you take care of these two steps that you see in this block diagram. So we did that. So what should be the output of the norm should be between 0 and 1. So back here, so you don't need to do anything about that. So just whatever you have in the output, you know that's a normalized value. So again, you need to save that somewhere in internal memory, right? That's the reason I use %md0. We already talked about this in internal addressing in previous video, please watch that if you didn't watch that video. So we say m% md0, which means we say, okay, I actually reserve a memory address or memory location. What its length is the double. So that means 32 bits. You select the biggest one, which is the 32 bits, that no dot you lose any of them, and save it that inside these place in your memory. So that means whatever you normalize, sorry, so let's to review what's happened here at the end. So you get this value from analog input 0, it changed that to this range, so then these normex normalize that and change this range from this to the 0 to 1. Where is that data? Is inside this address in the PLC memory, which is a percentage MD0. So now you need to scale that. So where is that data? Here in the value you put percentage MD0, so that say, okay, whatever I have here, you use that. So see, this is exactly what happened. So the output of the norm X should be somehow input to the scale. So this is what happened here. I put the value exactly the same address in the memory, so whatever you have here is transferred to this value. So now, what should be the minimum and maximum of the range? Because this input is just between 0 and 10, I put 0 to 10. So again, that's depending on your application. It could be any range. So here are my voltage that I'm going to change in my power DC power supply 0 to 10. I want to see the same value in the output. That's the reason I give 0 to 10 volt here. And where you could see the output, I save that output inside the M% MD4. So again, remember, you shouldn't put MD1, MD2, MD3, because this is 32-bit, you save in the MD0, so the next one should be 32-bit in the other side. So that means if you don't want to have the conflict of the addressing and lose the data that you already keep inside the percentage MD0. That's the reason I put MD4, which is MD0 takes 32 bits, so then MD4 start after that, so that means no conflict of the addressing. Again, if you don't understand this, watch our previous video, internal addressing in PLC. So the output, which is the scale data between 0 and 10, I should see able to see here inside this variable, and also I could see here. So definitely you could, if you want to use that in any other application, after you saving inside this variable, you could use anywhere else that you need. So let to uh, let to run the program. So I already loaded for saving the time, and I'm in the live mode. Let to see what's happened here. So let to just start with the small value. Let I go down to the 1 for example. So then go back to the other values. So this power supply that I have is not very accurate. So we actually made ourselves in the lab with the students. So it's okay, at least for this application that I have. So now what's happened? I put in 3.1, 3.5. So that means if this is my sensor, convert the quantity value to the 3.5 volt. So then I should be able to see that in my program. So see here you have the norm, which is between 0 to 1. Right now is 3.4. So then comes here and scale between 0 and 10. That's the reason I exactly see the similar value 3.5 here. Just watch this value. I'm going to increase that. So see now I'm going to the 4.7. You have the 4.5 or 6 close. The exactly same value. Go up. 5.3, you have almost 5.3. Go up. What I have here on my power supply, so 6.5. Almost 6.5 here. So go up, it's actually 8.5. You have the same here. So 9, and let to go to the all way down to the 10. Exactly, let to adjust to the 10. I have 10 here. So now you see you have exactly the same value. So see, the range is 0 and 10. Whenever I give 10, definitely should be 1. And here even you see what's the value of these. Yeah, this is 1, and then it's actually again change that to the 10. So that means 10, close to the 10, and if I go all the way down, you could actually get the same number. So what's happened here? I use analog input, so I'm able to change the voltage. I'm able to interface my sensor for this case and able to read the data, sensor's data, and have that in ladder logic. So you could connect any sensor, right? So definitely any sensor that you use could you replace um, with this variable power DC power supply. The sensors, whenever the physical quantity change, so it's change actually the range of 0 to 10. So definitely you could replace that with your sensor and you are able to read the sensor's data. So let I show you one example. Let you comes here. Suppose we want to do this. We have actually the tank. So there is a water inside that. You add the level sensor here. So this level sensor able to sense this level of the water that you have here and convert the level to the value between 0 to 10 volt. So that means whenever it is the tank is full, so which is 100 centimeter here to here, so it gives you a 10 volt voltage. So whenever there is no water on it, which is the 0, the height is 0, the level is 0 centimeter, it gives you a 0 volt this sensor, this level sensor. Definitely whenever it is middle, so that means whenever the water is in the 50 centimeter level, so it gives you a 5 volt. So that means, so it is exactly the same case. What these level do here is do exactly the job of the power supply. But this time, instead of you manually change that between 0 to 10, this physical quantity, which is the level of the water, it's actually able to change from 0 centimeter to 100 centimeter and change your output of the sensor from 0 to 10 volt. So that means if you want to make a program that able to use the PLC and somehow show you where is this level of this water, so definitely easily you could do with using the same program. So the only difference that or the only change that you need to make, so is it any change of A0? No. So you connect your sensor to the A0. So any change between these min and max? No, because analog to digital converter inside the PLC is same. So it's normalized the value, then here you get the same normalized value, no change. But here do you want your physical quantities between 0 and 10? What is your physical quantity here is between 0 to 100 centimeter. You want to see that data, you want to get that data in your PLC. The only change that we need to make, to make this to 100 centimeter and change this guy here to the 0. Technically you don't need to change that, that was already 0. So that means whatever I'm reading as a level, so I want to see that between 0 to 100, which is shows me what's the level of the water. So now let me to load this and see really we are able to see the water level in our program or not. So I already loaded. You say you want to make changes. I say yes. So it's going to do. Okay, so see, suppose we don't have that tank here, but definitely suppose whenever it is in the middle, so it gives you a 5 volt. So for that reason, I'm changing this to the 5 volt, which means I somehow telling, okay, the water level is on the 5. So let's do just if I could exactly change. Okay, what you expect to see, the 5 volt should be 50 centimeter, right? So let's do back. What you have here, 49.8 centimeters, which is very close, right? So that means if you change the level of the water, so definitely you could change from, I don't know, if this is 1, so it means what it means. It means actually if it's 2, so 0 means 0, so the 2 means around 20, that's right. So if you go to the 50, definitely should be 45 volts should be the 50 centimeter. If you go all the way to the to the 10, it should be shows you too close to be 10. Should be 100, which you see to 100. So that means it doesn't matter what sensor do you use, because sensor technically do this, change the your range from the 0 to uh, in the range of your physical quantity, you change that to the range of the 0 to 10. So that means it doesn't matter what type of the sensor do you have. So definitely here you should have 0 to 10 whenever your physical value change whole way minimum to maximum, right? So what it means you could use exactly the same circuit and you could actually interface or connect any of sensor to your PLC and you are able to get its data in your ladder logic and in your program. So I hope you find these video useful. Thank you for watching.